أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Previously, we spoke about receptive and perceptive fields, and we spoke about various experiments from Weisel's work in the 60s all the way down to most recent work that we've seen in connectionism. So, just to recap very, very briefly here, this is the work I looked at by Hubel and Weissel, looking at the visual field of cats over here. Okay, I'll attach everything on YouTube as well. Essentially, the idea is that specific neurons in the striate cortex is this part of your brain structure that processes all the visual stuff. By stuff, I mean objects, patterns, texture, so on and so forth. And then we looked at various other theories concerning receptive fields and the visual system. One of them, one of the models we looked at was by Ruckel, Cave, and Koslin, identifying objects in different locations. And one of the experiments we looked at was this one here, which you can also see on the live stream right here. So these are two fascinating sources. For those interested, they can certainly look into. So this is image in the brain, and the other one is this one, the self and its brain. Despite Popper being a controversial socialist philosopher, still a great neuroscience book. Right, so today we'll be focusing on the Wisconsin card sorting test, also known as WCST. This is a neuropsychological test, as you can tell on the screen. And the idea is to measure cognitive flexibility. Cognitive flexibility entails where you're essentially looking at how your mind can match patterns and sequences within a framework using different rules within various categories, whether it's across categories or within categories. So, for example, the most common type of test usually has cards, and the best way I can show you this is on the screen here. So, you have this white card with the red dot, you have a white card with two green stars, you have another white card with three blue squares, and then you have a white card with four yellow pluses, and then a red card with two yellow pluses. The idea here is to essentially see which ones match. So what I'm talking about is this. So cognitive flexibility. The idea is that which one does this match with? Because if the rule is color, you're looking at this. If the rule is numbers, you're looking at this one. If the rule is shape and symbol, you're looking at this one. If the rule doesn't exist, then you probably can go with either or. There's always one disassociated piece of information that exists. A bit to throw someone off, really. But there's an issue because with this particular test, though it's looking at reinforcement and cognitive flexibility and set shifting means the idea of moving from one idea to another or from one task to the other. There are some errors as human beings we make, and this is not a test that is all and be all. There's certainly situations where you have to really gather information where it's easier to measure those errors. Okay, so first and foremost, This particular test is a neuropsychological test of executive function, and it looks at various abilities that we human beings have. One of them is forming abstract laws. Second is shift cognitive strategies, as I mentioned, using feedback to guide behavior. So, for example, human beings, we use feedback when it comes to understanding the world around us and ensuring that we are not really out of place when we are looking to improve the knowledge we have, correct the knowledge we have, or add into the knowledge we have. So, correction, removal, and understanding, these are completely different concepts, which I'm not going to go into today. But when I do my neurophilosophy lectures, I will certainly step into things such as abstract concepts, things such as why they exist, how they exist, and what's their utility, what's the use of, for example, having an unspoken rule, as they say in English, of something. So, for example, the unspoken rule is never ask someone how much money they make. Unless you know the person, great, but it's an unspoken rule at the end of the day. In any case, and last but definitely not least, the other ability that's being measured is inhibition to incorrect responses. So if you know that the response you're getting is incorrect, how do you recognize that that's incorrect? Now, that is a form of feedback, but the brain, I would argue the mind and the soul, has this ability to recognize bad as well as good, but it seems to discriminate both within the space and time environment we are in as human beings. So, again, this depends on how competent you are, what you've learned over the years, so on and so forth. So, that's where we are at the moment. So, another thing about this test also is that the rules are not explicitly told. The rules are just mentioned, whereby one has to really look and understand what's the best possible thing to do. So, it's never really explicit, as in, you're not exactly told that, okay, this is the rule, follow it, draw a conclusion. The idea is problem solving, inference. Inference means you have some information and you're drawing a conclusion or the best possible outcome from the data that you have. Okay, and sometimes there are situations where the data you have is incorrect and you make a wrong inference, or the data you have is correct and you make a wrong inference still. So in either case, it's imperative that you have the correct data at first. So again, this really falls into different neuroscientific methods and their limitations and so on. But for today, we're just focusing on the actual test itself. So after a period of getting the pattern and response correct, the rule suddenly changes, and then the participant must detect this shift and adapt. So, for example, it would be color, 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 and all of a sudden it's shape. And you're like, whoa, what do I do now? So, this is called cognitive flexibility. We see this every day. For example, you have issues in your personal life trying to understand A, B, C, D, E. And eventually, what happens is that you fall into a particular situation that you can't come out of. It could be a financial situation, it could be an intellectual one, it could be a health one. There's many situations where you have to really adapt So flexing that muscle is called the mind's muscle is extremely important. Anyway, so the Wisconsin card sorting test, which is the focus for today, was developed in the 40s, and this was a result of understanding how does damage to the frontal lobe, which is this portion here, affect thinking, reasoning, and flexibility. So historically, and to a large degree, very accurately, the prefrontal cortex is known for reasoning, it's known for thinking and adaptability, otherwise known as flexibility. Okay. In fact, I have an interesting book with neuroscientists I don't really agree with, but I think he summarizes it the best, in my opinion. He was definitely. I'll pull up his paper. Up his paper on YouTube here. His name's Joaquin Fusra, and he's in his 90s, based in Spain. And I like how he describes the prefrontal cortex in his book. In fact, he has an entire book called Prefrontal Cortex, so pretty sure I have it on my laptop here. Yep, here we go. 12th of Feb 2025. Okay, so right, so prefrontal cortex. We are gonna go with his definition here. Let's see. Right, so the prefrontal cortex is the cortex of the anterior pole. So this is your anterior pole, posterior pole is behind. For the frontal lobe, with the adjective prefrontal, we make loose, if not improper use of the prefix pre, literally place that cortex in midair. Bit of a sarcastic comment. Nevertheless, that designation has been condoned by so much usage that it seems unwarranted to discard it for semantic reasons. Here, the prefrontal cortex is defined as a part of the cerebral cortex that receives projections from the medial dorsal nucleus of the thalamus. So you have the thalamus, which is just above the hypothalamus. So right in between, towards the bottom, okay, is a nucleus through which projections come into. It takes into consideration the possibility that a relationship with a well-defined thalamic nucleus reflects an identifiable functional group of functions. Okay. Furthermore, the functions of the medial dorsal nucleus are not well known, and the prefrontal cortex is also connected with many other cerebral structures. That is true, such as the hippocampus. So, the basic function of the prefrontal cortex is the representation and execution of new forms of organized, goal directed action. All the so called executive functions of the prefrontal cortex serve that superordinate function in one way or another. Now, why I took time to take out this definition for you guys. So, before we move forward, I think it's extremely important you know why on earth such a simple yet complicated test exists. one of the biggest mysteries of neuroscience is the brain itself. That's the irony. And in particular, the prefrontal cortex, right? And there are many connections from a Quran point of view, from an Islamic point of view, where this part of the brain certainly has some significance to our overall being. I think it's one of the main centers, main areas of the brain, which is your orbital cortex, which is basically this region. You have your prefrontal cortex, so from here to here. Interestingly, this is the first part of the face that's formed when you're in your mother's womb. Anyway, this, and then from here, projections go to here. So this entire process encompasses the visual system, reasoning, thinking, flexibility, and so on. Now, what was happening in the 40s is that neurology and psychology were coming together. So we eventually in the 50s you had a field called neuropsychology, which is quite well known now, right? So neuropsychology looks at essentially merging neurological findings and psychological theories. Okay, and of course this entails clinical as well as experimental applications. So IQ tests, which I'm of the opinion is a complete scam, but in any case, just to test human beings and their intelligence, they were very insensitive when it came to frontal lobe damage. And such patients scored normal on intelligence tests. However, clinically, they showed rigidity, so they were very rigid in their formalization and organization of knowledge and reasoning. Poor planning, perseveration, which means their ability to take in information, and inability to adapt to change. So, people with frontal lobe damage, this could be due to accidents, this can be due to fighting, such as boxing and MMA. This could be some genetic, though rare, genetic issues. Certain neurological disorders as well can lead to prefrontal damage. So, in any case, researchers required a task that picked up how people think, essentially, yeah, and not just how much they know. So, there's a difference between how you think and how much you know. You might know everything about business studies and the history of money and how money works, for example, but when it comes to its application, it's a completely different story, completely different ball game. So there's always this tension between someone who teaches business studies and a student who graduates from business studies as compared to someone who's from the streets, as they say, who went through thick and thin, the good days, the bad days, and built businesses and built their wealth that way. Sometimes you have people in the middle, usually they're known as criminals, i.e., politicians, who lobby with different companies and pass laws and they make a certain fraction out of it. So they have knowledge of the industry and network connections within certain networks, and also know how to move money and legislation around. Okay. In any case, clinicians observed that patients with prefrontal cortex damage could explain rules perfectly, yet fail catastrophically, catastrophically to apply or change them. There was an obvious mismatch between knowledge and behavior, which became a definitive feature of frontal lobe dysfunction. So that was a big mystery, as in how can they explain rules perfectly but they can't apply them? It doesn't really make sense. How can you explain how to walk but you can't walk as a human being? That's why it's called executive function, to a degree, because human beings are designed by Allah to function in such a way where we can think and reason and adapt and recognize patterns and navigate in the world. In any case, the Wisconsin card sorting test was created by two researchers, Grant and Berg, in 1948, an experiment to study concept formation, hypothesis testing, and behavioral flexibility. Very simple design, as I've shown you. Simple visual cards, clear feedback, no explicit instructions about the rule, and repeated unexpected rule change. So we see this in gaming as well, whether it's your adventurous GTA, Red Dead Redemption type games, or whether it's your everyday games such as Fruit Ninja or Candy Crush, whatever other games people tend to play. Now, this test eventually became cognitively demanding but perceptually simple, as I mentioned, and isolating high order control processes. So, high order control processes is something that I can explain with an example better, where you need to recognize patterns, you need to recognize how things tend to go from A and transform into B, and then C, and then D, and then E. That's higher order control processes. For example, reading a legal document. Thus, though linguistically, it's a higher order controlled process. Reciting the Quran, definitely the highest order of control processing. So, language plays a big role when it comes to such processes. Okay. Now, in essence, the test is, if now this, then this later. If now this, then that later. If now this, then that later. And all of a sudden, if now this, then this. So there's that sudden change that they're looking to measure. So why is this well known? Well, there's a few reasons why it's well known. First and foremost, sensitivity to prefrontal cortex damage, as I mentioned already. Preservative errors, so using the old rule despite being told not to. So the inability to recognize. So preservative is a psychological concept here, which I can show you. Preservative describes something relating to preservation, a psychological and neurological term for persistent repetitive repetition of words, thoughts, or actions, even when inappropriate or stopped, often seen with brain injury or conditions like autism, ADHD, dementia, indicating an inability to switch tasks or ideas. It's getting stuck on something, like dwelling on negative thoughts or repeating phrases. Excuse me. Interesting. Helm Estabrooks is the one who has written a paper on this, which, if you're on YouTube or TikTok, you can see there. Okay. Problem of preservation. According to Allison, the term preservation was used first by Nasser in 1894 as a label for the repetitive production of the same response to different commands. No doubt the phenomenon called preservation was observed by clinicians much earlier than that date, because it is a very frequently occurring behavior associated with neurological disorders of the brain. So you can already see how neurology played a role in this. And then with neurology plus neuroscience, you had psychology merging together to make neuropsychology. So it's been around for more or less 120 to 130 years. So this is something that the Wisconsin card sorting test has been looking at. Okay, that's number one. So errors when it comes to repetitive kalam, things that you are saying again and again and again, despite being told this is incorrect, this is not right. Similar to when a child does something again and again and again, and you tell the child, hey, this is incorrect. The child doesn't have brain damage, obviously, it's going through a developmental phase, and there's stages, and then a transformation eventually happens. But everyday individuals who eventually get a knock on the head or have blunt force trauma or something along those lines, they were showing such signs. Okay. Second thing is failure to shift strategy. So they're unable to adapt and change their strategy when put in a unsuspected situation, in a situation that they weren't expecting to be in the first place. Third thing is reduced ability to use feedback. So when you have an appraisal when you work somewhere, which is a glorified version of giving feedback, or when you have a customer and they give you feedback, or when you look at feedback online, or when you sit down and dwell and reflect on your day, on your year, on your life, you try and pick out things that you're aware of, and you state to yourself, shouldn't have done that, shouldn't have said that. I'm glad I did this. I'm glad I took that. I'm glad I spent money here. I'm glad I met him. I'm glad I avoided her, so on and so forth. So, this ability to use feedback was reduced in people with prefrontal cortex damage. Number two is operationalized preservation. The pathological persistence of a response despite negative feedback. WCST turned a vague clinical observation into quantifiable cognitive phenomena, which is a big feat in neuroscience, taking a very simple experiment and quantifying something that is clinical and anatomical in nature. For example, another example I can give you is measuring attention spans of, for example, Gen Z, Gen Alpha, because their biochemistry has been messed up by corporations and organizations majority owned by Zionists and Jews, whether it's your fizzy drinks, whether it's gaming, whether it's corn, whether it's movies, their dopamine loop, as I talk about in detail in my video on YouTube, dopamine of dunya versus serotonin of sabr. I explain the dopamine loop, but in a few words, it's where you want more and you want more and you want more and you want more, and that cycle keeps on going until you reach a breaking point. And that breaking point entails many symptoms and has signs of mental disorders. So your biochemistry is now dictating your behavior, at least at the most reductive level that we can observe. And using similar tests, such as measuring attention spans, where a very simple experiment is there'll be a shape, for example, a black triangle and a gray background on a screen. You have to memorize and think what it was. You have to keep it in your mind. And another stimuli is shown, for example, a green dot with a white background. And then it will ask you what color was the square. And then you have to think, oh, was there a square or not? So it's similar to the Wisconsin sorting test, but here you're not really sorting anything categorically. It's more within the moment. So it's starting from T naught, which is T0, and then working on from there. So it's a sequential task, really. And what's been observed is that people get a lot of their answers wrong when it's fast and when it's a situation where they have to jog their memory, and subsequently they fail the experiment, as in they get most of the answers wrong. Okay. So Third is impact on executive function theory. The Wisconsin sorting test helped solidify the modern concept of executive functions, which we've discussed earlier. Clinically, it's been widely used in studying frontal lobe lesions, traumatic brain injury, I've mentioned, schizophrenia, which I haven't stepped into yet, but it's a very interesting area, schizophrenia in and of itself. There's an interesting book called The Neuropsychology of Schizophrenia. It's by, is it Larry or Lawrence? Can't remember now. Actually, let me double check here. Neuropsychology of Schizophrenia. Anthony David came out in 1994. It's been quite some time. Hmm. Okay, right. So, yeah, I haven't really stepped into it because it's a massive, 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 massive field, schizophrenia. So, yeah, fascinating interdisciplinary field. Anyway, so you have Parkinson's as well, ADHD, and dementia. Now, of course, there are limitations when it comes to this particular test. So, one of them is that it has low process purity and multiple cognitive demands. So, that is an issue because if it's low process purity, it will yield high number of errors. And when there's multiple cognitive demands, to a large degree, it's difficult to isolate a particular behavior from an experiment because an experiment you need the whole thing, right? Between subject, within subject, you have your statistical t-test, you have your z-scores, you have your chi-square tests depending on the matrix, 3 by 4, 4 by 3, and probability testing, so on and so forth. So I guess you can say that it's the case with almost every experiment, but that's what I could find when it came to limitations. So, still influential as it linked to behavior to a specific frontal system, it inspired modern task designs, example, task switching paradigms, the one I was speaking about earlier, the green dot and then the triangle, and then the question is what color was the square? Okay. Key concepts cognitive flexibility, the ability to adapt thinking and behavior when rules, goals, or environment change. For example, the Jenny aside happening in the world in Gaza, and also not to forget how people's financial situations change, how the personal situations change, how, for example, ICE is terrorizing people in America, how they're seizing ships, Muslims are at each other's necks these days. UAE, USSR, Europe. So again, how do you adapt your politics? How do you adapt your finances? This, in a sense, is addressed by cognitive flexibility, and actually things, some techniques can be used to improve cognitive flexibility, which I'll discuss at some other point. Rooted in frontal lobe neuropsychology and later formalized within executive function theory by Norman and Schlieff and Miyake et al. I haven't looked into Miyake's stuff, but Norman and Schlieff, very famous researchers, they came up with the Tower of London problem, where you have these three blocks stacked up on each other. I'll show you in one of the books I've been reading, and you have to fit it according to the right sequence. They use this often with children when it comes to understanding how quickly developed they are, or if they need help with development when it comes to their cognitive skills. So as you can see here, so just for your reference, it's cognitive psychology, neuropsychology, pardon, cognitive neuropsychology by McCarthy and Warrington from University of Cambridge, I think. Yeah, McCarthy, Cambridge, Warrington from London. It's a very old book actually, and I found this by accident in a bookshop. So this is actually from 1990, so this is over 30 years old, still very relevant. So as you can see, this is the Wisconsin card sorting test. I'll attach this on the video as well. This is for your understanding. It's again a very influential experiment. And Norman Schlieff, well, in particular Schlieff, they have the Tower of London problem. So just to give an idea, this is the starting position here. Okay, as you can see, there's a black ball, a gray, and a white one, and there's three. What would you call these? Not pegs. Three poles through which these balls go into, right? As you can see here. Now, the goal is to go from here, somehow moving the balls around, changing their position, and it becomes like this. So the black is at the bottom now, and the gray is at top. So this is one of the famous experiments as well, looking at task shifting and measuring cognitive flexibility. Now, in the Wisconsin card sorting test, cognitive flexibility is not just one action, it emerges when a participant abandons an old rule, infers a new one, and then applies it consistently. Now, this type of experiment, pardon me, this concept is agreed with predictive processing accounts and Norman Schliess's supervisory system, which relates to working memory. And working memory, we're looking at Alan Bradley's model, which is the widely accepted one. And yeah, extremely influential as well, that memory model. Disagree, Rick Cooper, his paper from 2024 outlines some issues and single deficit views. So the Wisconsin card sorting test is not measuring pure flexibility. Okay, interesting perspective. Set shifting, the mechanism of switching from one mental rule or set to another. Classical cognitive cognitive psychology concept, seen operationalized through WCST, and task switching paradigms. So just before we leave, I'll give you an idea of the kind of memory model we're also looking at when you are identifying colors, shapes, sizes, number, positioning, so on and so forth. Okay, so should be here, pretty sure. So many books on memory. Okay, what I'll do is I'll just show the working memory on the YouTube screen. Working memory paradigm and value. This is the most widely accepted cognitive neuropsychological framework. So the best one, they're all more or less the same. I think this is a better representation. I think it's from. Okay, so yeah, so this is from the 1986. So this is from the 1986 Badley's model of working memory. So you have the central executive where your thinking, reasoning, and everything else is stored in. What do I mean by stored in? It's not a vein in your brain. It's not a blood vessel. It's all abstract. Okay, that's the beauty of science. You can put abstractions forward to explain the concrete, and it's never 100%. This is what people mix up between religion and science. They go hand in hand. Quran explains why you're here. Science explains how things exist whilst you're here, how your brain works, how plants preserve themselves, how the water cycle of the earth works, how money works, so on and so forth. Why you're here is what the Quran explains. But in any case, going back to Badley's model here. Okay, you have the central executive, all the information is the visual spatial sketch pad. This is it's quite vague, but in its simplest form, the visual spatial sketch pad is where you're outlining and imagining what's in front of you by virtue of what you knew. And the phonological loop, I think, is the language involved in you understanding and remembering it. So, yeah, central executive controls information flow, sets goals, and directs attention. Okay. Then you have your episodic buffer, which combines sounds, visuals, and long term memories into short temporary experiences with limited capacity. And then you have your visual sketchpad, which holds and manipulates visual information like a mental canvas. So you're canvassing. But when you're canvassing, you need a reference. I'm not sure if anyone here has done art, but when you canvas a building, actually, no, that's incorrect. Still, still life art. So, for example, a glass of milk on a table with fruits around it, that's still life. You have a point of reference. You have a glass, you have the milk, and you know the glass texture is different to the milk, and the milk goes in the glass, not around it. Otherwise, it looks messy, and so it doesn't make sense. So the information you have is like a mental canvas. And phonological loop, it briefly stores and rehearses verbal content like speech, words, and sounds. For instance, if I say to you, a squared triangle, it doesn't exist. A squared triangle does not exist. So it's quite redundant taking that serious. So the phonological store is it temporarily holds auditory information, like someone's voice that you heard a while ago, and all of a sudden you hear it again. And then articulatory rehearsal process. The articulatory rehearsal process repeats sounds in the mind to remember. So when you're reading, sometimes you read something in your own voice, but if you're reading a character from a novel or a book written by your favorite football manager, for example, you might read it in their voice. Or a comedian who's written a book, you might read something in their voice, like a catchphrase. So all of this is part of the working memory model. And this is extremely important when it comes to tasks that is looking at cognitive flexibility. Now, why am I talking about all of this? This is essentially me, inshallah, looking to improve on this model. There are limitations, there are things I'm still looking into, but I thought it would be nice to move from the actual neuroscience into the cognitive neuroscience space things. So, just before I go, I'd like to play this short video describing the regions of the brain by Leonard White doing bits at Duke University School of Medicine. So let's play what he has to say here. Actually, shift this. Can I shift it? Yeah. Okay.
Ready to leave this dorsolateral sector of the prefrontal cortex and spend just a few minutes introducing the orbital and the medial aspects of the prefrontal cortex. Now, these parts of the associational network of the frontal lobe bear many functional similarities to what we've just been describing for the dorsolateral sector, but there seems to be some very important differences that pertain to the inputs and outputs of these cortical networks relative to the sources of the information and the effector systems that they gain access to. The dorsolateral prefrontal cortex is working on explicit information. That is information derived from our special sensory systems, from our memories, from other aspects of cognition that we can access with our language systems. We can talk about them, we can give them names, we can describe them with our verbal faculties. The orbital and medial sector of the prefrontal cortex, however, seems to be operating principally on implicit information. Information derived from our emotions that are informed by our visceral senses. Information that is united through these prefrontal networks with our faculties that are involved in planning for the future, but those plans are being motivated by these sources of information that are just more difficult to describe. Consider, for example, the challenge of articulating in verbal terms the content of an emotion, such as anger, or fear, or happiness, or sorrow. I can do a much better job describing, for example, the texture, the dimension, the color of this object that I'm holding in my hand than I can use my verbal faculties to reveal for you the content of the twinge of anxiety that I may be feeling at this very moment. So, our orbital medial prefrontal cortex is engaged in the processing of emotion and integrating that emotion with our faculty for reason, for decision making, for planning for the future, both our short-term as well as our long-term. And it's this future thinking aspect of associational processing in the prefrontal cortex that can lead to advantageous decisions as our lives unfold, or perhaps disadvantageous decisions if our motivations are simply driven towards short term gains, impulsive action. So, part of what this orbital medial prefrontal cortex does is suppress the impulses that might lead to the acquisition of short term gain at the cost of a more long term strategy that would lead to advantage, be it in the domain of social relations, in financial matters, or whatever the dimension of life that we might want to consider. We're going to have much more to say about this orbital medial sector of the prefrontal cortex when we talk about emotion. And we'll consider how the amygdala in the anterior part of the medial temporal lobe has an important role to play in the experience and expression of emotion, and how the amygdala is intimately connected to this orbital sector of the prefrontal cortex. Now, a modern understanding of the importance of this orbital and medial part of the prefrontal cortex and integrating emotional experience with our decision-making faculty began with the story of one individual who passed away about 150 years ago. His name was Phineas Gage, and I'm sure he's known to many of you. Phineas Gage was an individual who suffered a horrific injury to the front part of his cranium, involving facial structures and, amazingly, a huge penetrating injury to the cranial vault that resulted in damage to the orbital and medial sectors of the prefrontal cortex. Now, this injury was reported in the local newspaper in Rutland, Vermont. That paper was called the Vermont Mercury, and one Friday edition in 1848, October 13th, led with the headline, "A Wonderful Journey Through Skull and Brains." Well, much has been written about Phineas Gage, especially.
Right, so he's going to talk about Phineas Gage. Phineas Gage is basically irrelevant for us at the moment. There was a man who had a rod go through his head, and he still survived, but he had issues with reasoning and thinking. So, if you're interested, this is what he looked like. He had a railway accident. So, this is what he looked like. Right, many years ago, 150 or so years ago. He looked like this, and his skull had a rod go through his, pardon me, a rod went through his skull. So that's his real skull. That's a visualization of what most likely occurred. So he's always been used as a textbook example of how one can survive even with severe brain injury. And yeah, it's quite remarkable, subhanAllah, how people can survive. I mean, Allah takes who he wills when he wants. So, what does your IMDb page? It's weird. Okay, right. So next, what we're looking at, hopefully tomorrow, is a research paper by again, TikTok viewers. Right. So tomorrow I'll be looking at paper by Rick Cooper. I think it was this one. Yeah, so very straightforward paper. Mathematics is interesting, looking at attention and feedback, action selection. So intrigued to know what's happening here. So here we go. We'll read the abstract for now. Okay. Keep life nice and simple for tomorrow, inshallah. So the Wisconsin car sorting test is commonly used to assess executive dysfunction, particularly in neuropsychological patients. Performance on the test typically yields two types of error: preservative errors, where participants persist in applying an inferred rule despite negative feedback; a set loss error, and set loss errors, where participants cease applying an inferred rule despite positive feedback. The two types of error are known to dissociate. In this paper, we apply an existing model of the WCST, the model of Bishara et al. 2010, to a novel dataset focusing specifically on the distribution of the two types of error over the duration of the task, using maximum likelihood estimation to fit the model of the data. We argue that the model provides a good account of performance of some participants but a poor account of individual differences. It is argued that this is because the model is essentially a competence model, which fails to incorporate performance factors, and that accounting for the different types of error, and in particular the error distribution during the task, requires incorporating performance factors into the model. Some consequences this for the broader enterprise of developing normative competence models are discussed. So quite easily, it's very difficult to understand individual differences because this model is a competence model, and it doesn't incorporate, because according to Rick here, fails to incorporate performance factors, and that accounting for different types of error, and in particular the error distribution during the task, requires incorporating performance factors into the model. Right, so it's a nice abstract here. Rick is one of my favorite researchers, and I've had the pleasure studying with him and in an academic setting working with him. He's really good at taking complicated things and making them brief. Anyway, action is prone to error. This is particularly true of sequential action that comprises multiple steps which take place over time. Errors in sequential action take a variety of forms. In some cases, steps within an action sequence may be repeated after the immediate goal has been achieved. In other cases, the immediate goal may be lost or neglected, such that individual steps become disconnected from that goal. Both of these types of error may occur when participants perform the WCST. This test is commonly used within clinical neuropsychology to assess executive, or more specifically, this executive function. Right, so this is interesting. Here we go. Miyake is mentioned here as well, which is nice. Very quickly, Miyake's paper is The Unity and Diversity of Executive Functions and the Contributions to Complex Frontal Lobe Tasks. Okay, it's an interesting sounding paper. For Miyake, found in sample of 134 US college students a statistically significant correlation between the rate of preservative errors on the WCST and performance measures on several simpler tasks that were held to assess the executive function of mentorship. Interesting. So there seem to be errors amongst American students that was statistically significant. Were committing preservative errors, which means they repeated steps within an action, even the goal was achieved. And performance measures on several simple tasks were held to assess mental shifting. Okay, so they seem to be failing more than improving. It's hard to discriminate. Right, okay, well, that's it for tonight's informal-ish session. Inshallah, tomorrow we're looking at this paper, breaking it down. I'm going to do a bit of homework when it comes to the mathematics here. You can see there's a matrix here, 3 by 1 matrix, action selection equation here. 3 by 4 match matrix formulation. Adjusting attention on the basis of feedback. Okay. Interesting. ماشي. السلام عليكم ورحمة الله وبركاته.